Iron core versus toroidal coils. Power versus precision in electronics. The iron core coil, the strong man of power. In the family of coils, each type has its identity. The air core coil represents freedom. The ferrite core coil represents specialization. And the iron core coil represents raw strength. Where the others excel in high-frequency precision, the iron core coil stands firm in the world of power handling, carrying heavy load with steadiness that has kept it indispensable in energy systems for more than a century. What are iron core coils? At its simplest, an iron core coil is a coil of wire wound around a solid iron core. The iron does not carry electricity but serves as a magnetic backbone, dramatically amplifying the coil's inductance. Iron is highly magnetic. It gathers and focuses a magnetic field created by the coil, turning what would otherwise be a faint ripple into a powerful surge. In doing so, the iron core coil becomes a workhorse for power systems. Transformers, heavy inductors, and energy transfer devices that keep lights on, industries moving, and cities alive. How it functions in power handling. The strength of the iron core coil lies in its magnetic amplification. The iron core concentrates the magnetic field, enabling the coil to handle high levels of current and energy without requiring an impractically large number of windings. This makes it ideal for power handling applications, such as transformers and power grids, stepping voltages up or down across great distances, chokes and power supplies, smoothing the flow of large currents, motors and generators, where magnetic fields and motion meet. Unlike the ferrite core coil, which shines at high frequencies, the iron core coil is most comfortable in the low-frequency, high-power domain. It is the coil you trust when brute force, reliability, and durability are required. Strengths of the iron core coil. The iron core coil is like a weightlifter. Its very existence is about carrying heavy loads. Its strengths are unmistakable. High inductance and small size. Because iron channels magnetic flux so well, fewer turns of wire are needed to achieve strong inductance. Excellent power handling. It thrives in circuits where large currents flow and where energy must be stored and transferred efficiently. Durability. Iron core coils, when built robustly, can serve reliably for decades in transformers, industrial machines, and energy infrastructure. Dependability in low frequencies. Unlike ferrites that specialize in high frequencies, iron core coils are most reliable at power line frequencies, 50-60 Hz, or in direct current energy storage. Limitations of the iron core coil. But strength is never without trade-offs. Iron core coils are not universal heroes. They are specialists in power. Their limitations include losses at high frequencies. Iron suffers from eddy currents and hysteresis losses when frequencies rise, wasting energy as heat. This makes it unsuitable for modern high-frequency switching applications. Weight and size. Iron is heavy. A transformer with iron cores can be bulky compared to one with ferrite at higher frequencies. Saturation. When the magnetic field exceeds iron's natural capacity, the core saturates, losing its ability to channel magnetism effectively. At that point, the coil stops behaving as designed. Heat management. Heavy currents and losses generate heat, which must be managed to preserve the coil's lifespan. The duration of working power. The iron core coil is not fragile. Unlike ferrite, which can crack, or air cores, which may demand more space than practical, iron core coils are built for endurance. When operated within their design limits, they can work for decades. Consider the massive transformers in old power stations. Many have been operating faithfully for 50 years or more. Their durability depends on one thing: respecting their boundaries. If kept cool, they last long. If driven into saturation or overheated, they degrade, their insulation breaking down, and their iron core becoming less effective. Thus, their working duration is tied not to fragility, but to discipline in design and operation. The identity of the strong man. If we imagine coils as characters in a story, the iron core coil is not the free-spirited wanderer air core, nor the subtle craftsman ferrite core. It is the strong man, the dependable figure who shoulders a heavy load others cannot bear. It may not be nimble in the high-frequency realm, nor as lightweight as its ferrite cousin, but when the task calls for stability, endurance, and sheer power, the iron core coil steps forward. It is the foundation of the modern electrical age. Without it, There would be no reliable distribution of electricity, no power grids, and no backbone for our technological society. The toroidal coil, the silent guardian. In the ever-expanding family of coils, some are bold and obvious. Massive iron core transformers humming in power stations, or delicate air core inductors singing in radios. Then there's a toroidal coil, which, at first glance, doesn't look like a coil at all. A ring of wire wound around a circular core, compact and elegant. It is a quiet achiever of electronics. It does not demand attention but protects circuits, conserves energy, and ensures that power flows smoothly without leaking chaos into the world around it. What are toroidal coils? A toroidal coil is a coil of wire wound on a donut-shaped core, the torus. Unlike straight or cylindrical coils, the toroidal design bends back on itself, enclosing the magnetic field inside the ring. This geometry gives it a unique character. The magnetic field does not leak into the surrounding environment as it does with ordinary coils. Instead, it is contained, directed, and harnessed with remarkable efficiency. The toroidal coil, whether wound on iron, ferrite, or powder cores, is therefore known for its silent discipline. How it functions in power handling. The toroidal coil shines in power handling because of its field containment and low energy losses. When current flows through its windings, the magnetic field remains almost entirely within the core. This makes it efficient. Very little energy is wasted in stray magnetic fields. Quiet. Unlike other coils, it produces minimal electromagnetic interference, EMI. Compact. Because its magnetic path is continuous, it requires fewer turns of wire and a smaller core size for the same performance. In practice, toroidal coils are found in power supplies for computers, audio equipment, and sensitive electronics. Transformers where efficiency and quiet operation matter. Chokes and filters and circuits that must handle high currents without radiating noise. They are the guardians of clean power, ensuring that devices function without buzzing, humming, or interference. Strengths of the toroidal coil. The toroidal coil is not about brute strength or flamboyant freedom. It is about balance and refinement. Its strengths include exceptional efficiency. Nearly all the magnetic energy is trapped inside, reducing losses dramatically. Low electromagnetic interference. Because the magnetic field doesn't stray, nearby circuits are safe from disturbance. Compact design. High inductance in a small footprint, saving space in modern electronics. Silent operation. Unlike traditional cores, toroids do not hum or vibrate significantly under load. Versatility. Works well in both low-frequency power systems and certain high-frequency filtering applications, depending on the core material. Limitations of the toroidal coil. But even silent guardians have their weaknesses. The toroidal coil, for all its efficiency, comes with challenges. Complex manufacturing. Winding wire evenly around a torus is harder than winding around a straight core. This raises costs. Difficult scaling. While perfect for medium power, very large toroidal coils are bulky and difficult to produce. Fragility of core. Toroidal cores, often made of ferrite or powdered iron, can be brittle and must be handled carefully. Limited accessibility. For certain repair or modification tasks, their enclosed shape makes them harder to work with compared to open core coils. The duration of working power. Toroidal coils are among the most enduring of all coil types. Because of their efficiency and reduced heat loss, they often outlast other coil designs in continuous operation. A well-designed toroidal coil in a power supply can function faithfully for decades, maintaining stability without degrading significantly. Their longevity is owed to their balance. They do not strain like iron core coils under saturation, nor do they scatter energy wastefully like air cores. If heat and overcurrent are controlled, toroidal coils become one of the most reliable long-term guardians of electronics. The identity of the silent guardian. If air core coils are freedom, ferrite coils are precision, and iron core coils are strength, then toroidal coils are guardianship. They embody quiet reliability, protecting circuits, conserving power, and doing their work unnoticed. Without them, our world of modern electronics would be noisier, literally and figuratively. Audio systems would buzz. Computers would crash more often, and sensitive instruments would be plagued by interference. The toroidal coil proves that power is not always about strength or speed. Sometimes, the greatest contribution is silence, balance, and containment. That is why it has earned its title as the silent guardian of electronics.